So to start out, the problem that we're going to do here is deceptively simple. So it looks like when you look at it, people think, oh, this is going to be easy. So sine of x plus cosine of x equals 1. And we want to, just to make it a little easier, we're only going to look for solutions for x between 0 and 360 degrees. So we'll restrict that so we don't have to do all the pi k stuff. The thing that's deceptively simple about this is no matter which way you rearrange these, you're always going to have a sine and a cosine, because there's no identity that allows us to just change a sine to a cosine or to just change a cosine to a sine. Is there an identity that involves both sine and cosine? So if we had squares, it would work. And so the trick to this problem is you take both sides of the equation. If you square both sides of an equation, it doesn't change the answer. However, it may alter the number of solutions, okay? So that's one thing to consider. If you square, you get higher degree, which means you may get more solutions than you should. And so you will have to check your answers. But if we do this, we'd have, this is basically going to be foiling. So this times this. And so if I FOIL that out, I'm going to end up with sine squared. I'm going to have a cosine squared at the other end. I'm going to have sine of x times cosine of x, and another sine of x times cosine of x. So I'll have plus 2 sine of x cosine of x is in the middle here. And if this was like a plus b quantity squared, you probably remember that that ends up being a squared plus 2ab plus b squared, or maybe not. But this is what it will look like. Is there anything here that we can work with? Isn't sine squared plus cosine squared equal to 1 using the Pythagorean identity? So let's replace it. So now I'd have 1 plus 2 sine of x cosine of x equals 1. And then I could subtract 1 from both sides. And now I have 2 sine of x cosine of x equals 0. Now we still have two different trig functions, but there are two ways to solve this problem, because isn't this now multiplication, not addition? And if it's multiplication, I can use the zero product property, because now it's equal to 0 on the other side. So that's one way to solve it. Use the zero product property, just break it apart into two pieces. However, people are going to be tempted when they see this 2 sine of x cosine of x. What is that? Yes, that's sine of 2x. And that looks a lot easier to solve for most people because it's one equation. And so they're going to go that route oftentimes, which there's nothing wrong with going this route. But if you do go this route, there's a trap waiting down the road. So we have to make sure we deal with that. So we have now sine of x, or sine of 2x, sorry, equals 0. And the easiest way to solve this is to let u equal 2x. And so I just have sine of u equals 0. And then I could go to my unit circle and I could find the places where sine is 0. And sine depends on y. So there's a 0. And there's a 0. So it looks like u equals 0 degrees or 180. Okay. But were we solving for u? We're solving for 2x. And so if we replace 2x here Well, how do I get what x is then? Divide by 2. So I'd have x equals 0 here, and I'd have x equals 90. Okay, so if we go back to the original equation, let's find out. So if I plug 0 in here, I get 0. If I plug 0 in here, I get 1. So that one works. If I plug 90 in here, I get 1. If I plug 90 in here, I get 0. So that one works. They both worked. But this is not the answer. Is this x? No, and it's twice as big as x, which means that you have to keep going. So you'd have to include 0 or 180 or 360 or 540, because if I take half of those, aren't they still going to be less than 360? So whatever domain restrictions you have, okay, you have to take in consideration what the domain restrictions will be once you've altered this variable. You've doubled u from what x was. That means its domain is going to be twice as big. So instead of from 0 to 360, u has to be between 0 and 720, which is twice as big as 360. Then once you've found those, then you can divide them all by 2. So when we're all done, we'd have half of 0, half of 180, half of 360, and half of 540, and those numbers probably look familiar to you. And so then this is actually the complete solution. Since you have a limited number of solutions, this is the easiest way to write it. You could also write something like, let's see, that would be 90 degrees K, and K between 0 and 3 for K and an integer. You could also do that, but it would be way longer than just writing the numbers, because this says you can do multiples of 0, 1, 2, or 3 times 90. So you can do 0 times 90, 1 times 90, 2 times 90, or 3 times 90, which is the solution. But as you can see, there's no advantage to writing that solution in this case because it's just as long. So I'm going to go back to what we had. We had 2 sine of x cosine of x equals 0. And what we could have done is we could have said, wait, this is multiplication. So using the 0 product property, I can divide this up any way I want. So like maybe here and here. So it's 2 things multiplied. Then I'd have 2 sine of x has to equal 0, and or cosine of x has to equal 0. This is the easier, or this is, for this problem, it is the easier way to go, but it didn't get at the heart of the dilemma that would come up if you chose to do it the other way. So that's why I did it the other way. If you go to your unit circle values, well, this is really just the same as sine of x equals 0. And this is the same as cosine of x equals 0. So all you have to do is figure out where sine or cosine would be equal to 0. And so if you go around, well, 0, 90, 180, 270. So if you understood that this is the easier way, like if you could think ahead to the solution, this is way easier to do.